Good morning, everyone, and welcome to Manitoba Agriculture Crop Talk webinar. If you have any questions during the presentations today, please type them into the Q&A icon on your Zoom toolbar, and we'll get to them at the end of each presentation. This webinar is being recorded, and you will receive a link to the recording. Thank you.
Thanks, Lori. I'd like to welcome everybody to the May 8th edition of Crop Talk. And today we're going to have Kim on again, and which is good because we've got a topic that been getting more and more questions about lately regarding water quality, spraying, kind of what we need to know about our water that we're using for spraying. And so I thought it would be a good time to get Kim on because being that we've gotten some rain lately, that some of the guys are that have been planning on doing some spraying have actually been held out of the field, and I think we don't have a lot of spraying done yet. So it's a good opportunity to maybe to talk a little bit about water quality and how it affects our spraying. And then after that, we had a couple of questions come in, and so we'll get to the crop scouting panel as well. Okay. Just got to advance my screen here. There we go. So a few highlights of the crop report that came out yesterday, and just to kind of give a kind of little bit of an outline or a briefing on what came out in that report. Seeding progress across the province really hasn't changed a whole bunch from last week. I think we're up to about 4% across the province. Cereals and peas continue to be the crops being planted. There seems to be, well, there's lots of those to go in, and they're the perfect time of year to get those in. So producers have been focusing on that. Central region continues to be the area with the most of the advancing in getting the crop in there, about 12%. Weeds, I think weeds are something that we've been talking about, and I've been out in fields and they're definitely coming up. So I think there's several different kinds of weeds that are showing up, and I think producers need to keep on top of that. So I think while you're out there getting the drill set or calibrating your drill, or just driving around in the field, take a look at the weeds that are out there, because we definitely need to start keeping an eye on those weeds, and making sure they don't get too big on us, making sure that we have a burn off plan in place. And like Kim has mentioned last week, using some of the products that are good for pre-emerge as well would be good, because this way you kind of get a double whammy on some of your weeds. So definitely get out there and be watching for the weeds that are coming. Spring wheat, barley, and are sitting at around 9% complete across the province, and again, the central region is the highest in percentage for acres of those completed. One of the things I did see is some of the early seeded, and it was barley that I was seeing in the field that was starting to break through the ground. In a couple of fields, you could actually start rowing the crops. So, some of those fields that were in fairly early took advantage of some of the warm conditions we had before the rain came, and those crops are coming up. And that's something to watch for too. With these rains, we've had some delays in seeding, delays in being in the field, and it's amazing how fast that some of those cereal crops are starting to take on moisture and starting to germinate. So it won't be long before they're poking through the ground. So again, if you're planning on a burn off, you better be keeping on top of those fields. Field peas planting is about 11% complete. We're looking at the area around the northern northwest area or region where there's the majority of the peas planted right now, about 25%. And when you look at the southwest, about 7% complete. It's amazing how fast the crop can get in. I know I was talking to a couple producers, and basically, with the equipment that they have now, they can get a lot of the crop in fast. So it'll be interesting to see what happens over the next week or so here. We're looking like getting some good weather think the rain's going to keep a lot of guys out of the field for maybe today yet, or for a good part of today. They are calling for winds, which will help dry things up. But I think a lot of producers might be back in the field either later today or tomorrow for sure. So I think we'll start seeing crop go in. And the way the forecast is, it sounds like we're not going to get a lot of rainfall in the next little while here. So we could definitely see by the end of next week, we could have a lot of the crop planted. Not a lot of the crop planted, but a big increase in the percentage of crop being in the ground. As you can see here, we're sitting, right around 4% for the province. Not a big change from last week, but again, with good weather conditions, this coming week will be, a good, or rest of this week and next week will be a good week for getting the crop in. So that's a brief, I guess, highlight of what came out in the crop report. Nothing too major regarding insects or diseases yet, but just a slight increase in acres planted. So with that, I'm going to turn it over now to Kim, and she's going to talk about water quality and spraying. So Kim, if you could take the screen, we can go from there.
Okay. Yeah. Thanks, Lionel. Thanks for having me on. I'm just going to get up and going here, and I'll get going on the slideshow. Just let me know when you can see me in slideshow or presentation mode.
Looks good, Kim.
Okay. Sorry. There we go. Okay. Yeah. Again, thanks for having me on, and I'm just going to go over some water quality information for you guys. I've been encouraging anybody who heard me speak this winter. I am quite concerned about, the quantity and quality of water that you're going to have access to this year for spraying. We're sitting in a lot better position right now thanks to these recent rains. We're not nearly, our dry conditions have been alleviated somewhat, although we still do have a long way to go before we fully recharge, the water reserves down deep in the soil. Or down, down in the down below. So we've got a ways to go, but we are definitely sitting in a better shape than we were even a couple of weeks ago. So I wanted to talk about basically water quality effect on herbicides. The first thing we need to talk about is cleanliness. And here we're talking about suspended silt and organic matter. Now, these will actually tie up certain products, especially glyphosate and diquat. But generally, you want your water to be as clean as possible anyways, because that affects your filters and your nozzles. You don't want anything plugging. But definitely, if you've got water, if you've got dirty water, that will actually antagonize or will tie up glyphosate and diquat, and they will not work at all. And that is something that you need to, that you need to have. If you do have dirty water, you're just going to have to filter it. And there isn't really any guidelines on this that I can tell you, but basically if you have a 5-gallon pail of water, you need to be able to see to the bottom of the pail. And ideally it should be as clear as possible, because we know we do spray a lot of glyphosate and we don't want that tied up. And this is the same principle if you've got, dusty, the leaves of these plants when you're spraying them are dusty. We know that glyphosate doesn't work. We know diquat doesn't work too if plants are really dusty. It's the same thing because the soil particles actually bind to the herbicides and then they don't work. So the first thing is to have clean water. It has to be clean. And after that, then we're talking chemistry. So we're talking mineral ions, and there's a lot of different things here. So I'll go over them, and then I'm going to show you some different water tests and just show you what to look for when you get a water test, if you are doing some testing and when you get that water test back. So when we're talking about mineral ions, those are the minerals that are in that water. And that's basically, that's the water as you're drawing it from the well or from, wherever source you're taking it from. So we're going to talk about there's things like hardness, there's bicarbonates, there's also iron and manganese. These actually can really affect when you're irrigating. So because they can oxidize and form precipitates that can plug screens and nozzles that when you're spraying as well, but also for irrigating. And so there's, that's a whole another talk on irrigation water. And this cannot be corrected with additives. So this is something that you just have to have, if you do have high iron and high manganese source in water, then you need to try to find an alternative water source for spraying. When we're talking about testing the water, one of the things that you'll see is something called total dissolved solids. And this is basically when they add up all of the calcium and magnesium and sodium, and then the sulfate, the chlorate, and the bicarbonate ions. And so these first three here that I'm circling, those are positive, those are cations, and these last three are negative, those are anions. But these are basically the problem ions that cause issues when we're spraying. Another thing you will see is that they will, lots of times you will see the bicarbonate listed. That is HCO3 with a minus here. Usually you'll see the pH listed, and usually between 6 and 8 is fine. If you're way outside that, then again, we need to be looking at different water sources. We don't have a lot of information on exactly how those extreme pHs affect herbicides, but generally if you're between 6 and 8, you should be fine. And then sometimes you'll see salinity or electrical conductivity of groundwater, of water in general, can substitute as a measure for TDS. So sometimes you won't get a TDS reading, but you'll get an EC reading, and it's basically a substitute for that TDS reading. And if it's just easier to measure at the lab and cheaper. So, and if the EC is less than 500, then there's probably no effect on the pesticides. So there's a lot in this slide, so I'll just go over it fairly slowly. When we're talking about hard water, we're really talking about just calcium and magnesium. And lots of times you'll see this reported as calcium carbonate or CaCO3 equivalent. But there could be other ions present like iron, potassium, nitrate. Those are usually not as significant. They do contribute a little bit, and I'll show you that when we get to a soil test. They do have a contribution to water hardness, but the big players are calcium and magnesium. So calcium and magnesium are positive charges, and this affects weak acid herbicides like glyphosate and amine formulations of 2,4-D. Other weak acids are things like glufosinate, your ACCAs or your group 1s, your group 2s as well. So again, any of your weak acid herbicides can be affected by by these cations. When you're talking about hardness, basically if it's above 250 to 350 calcium carbonate equivalent, it should be treated. And then when we're talking about bicarbonates, which again is different than calcium carbonate, but bicarbonates are usually associated with high sodium or lots of sodium in the water. And this can also affect DIM herbicides and 2,4-D amine. And again, above 500 parts per million may need treating. So again, your things like 2,4-D might be affected by both hard water as well as bicarbonates. So when you're getting a water test done, that's usually on the water test. This is actually some information from Saskatchewan. They have a really good fact sheet. It's quite long. There's lots of information in it, but it's a very good one. And it's down here. It's from Saskatchewan Agriculture, Water Quality and Herbicides. It's a really good fact sheet. So I would encourage you to read that or have that on hand if you've got questions on water quality. And they talk about water hardness guidelines for glyphosate. And generally, we talk about this parts per million calcium carbonate equivalent. Generally, if you're under 350, this is the maximum water hardness. If you're under 350, that's still good for the low rates of glyphosate used for annual grass weeds. If you go higher to the 700s, as high as 700 parts per million calcium carbonate equivalent, then basically you need to be using higher rates of glyphosate in order to, because some of that glyphosate, if you're not treating that water, then that glyphosate is going to be tied up in the water. And this is to where we say, if you're in between that 350 to 700, this is when you drop that water volume back on glyphosate. You can drop down to 5 gallons. Basically, you want less of that water and more of the glyphosate in the mix, because you've got that that means there's less of these cations, less of the calcium and magnesium that's going to tie up the glyphosate. But at the end of the day, if you've got good water, though, there's no reason to spray glyphosate at 5 gallons. And we know that especially if we're mixing glyphosate with some burn-off products in the spring, and some of those are contact herbicides, we want to make sure we have good water coverage or good spray coverage. And a lot of that is water volume. So the only reason you would need to be dropping the water volume back is if you've got hard water and you're not treating it. But at the end of the day, we would still like to see you using as much spray volume as you can, because you'll just get better coverage that way. When you're talking about hard water and 2,4-D amine, ideally you would use a different water source. You would use the ester formulation instead, and lots of times we do use the ester formulations. If you are using the amine formulation, you would use the maximum rate. And you can also, if you are still using the amine formulation, use a non-ionic surfactant. That would be something like AgSurf or Agro 90 or any of those non-ionics at 0.1% volume per volume. And that's 1 gallon per 1,000 gallons. And actually, this is just a plug for Corteva has a really great little app on your phone. And if they have a water volume, or they have a adjuvant calculator on it. So if you plug this in, it'll actually tell you in liters, because we're selling lots of our products, or all of our products are sold in liters. So anyways, if you are not sure about how much non-ionic surfactant or how much of any surfactant to put in, Corteva has a good on their app. They have a calculator, which is really, really nice and really easy to use. So this is actually straight out of our guide to crop protection. This is from the glyphosate page, and it's on page 280 this year, and I've just highlighted, we've got this section in here called effects of growing conditions, and here they say hard water with quotation marks around it. So again, hard water, which would contain mostly calcium and magnesium, possibly some iron, will reduce the activity of glyphosate products proportional to the level of hardness, reducing the application water volume and or adding ammonium sulfate. And here they tell you 1.2 kilogram per acre, which is the dry, or 2.4 liters per acre, which is if you're using the liquid, will reduce the negative effects of low levels of hard water ions. If water is extremely hard, which is greater than 700 ppm or 40 grains, grains is an old term, you don't hear that very much anymore, but some older publications still talk about grains of hardness. Anyways, but we mostly talk about parts per million. So again, if you're greater than 700 parts per million, another water source should be found. They also say that dirty water or water with suspended soil or organic matter will reduce control. So again, that's right on the glyphosate label, and that is right in our guide to crop protection under effects of growing conditions. So I just want to show you, if you are going to be doing some spray water testing, I would recommend either AgVise or Winfield. They both have very, very similar. Well, you'll see when I show you a Winfield report in a minute. But when you send a water sample off to AgVise, you will get a report back that looks like this. And they will actually tell you here, in this case, it was well water. This is a couple of years old, this sample. There's a pH is 8.1. They've got sodium here. They've got calcium, magnesium, potassium, iron, and then EC. Again, that's electrical conductivity. They've got hardness in here. Now this water looks like it's really hard because it's equivalent calcium carbonate. That's 907 parts per million. That's over that 700 level that we talked about for glyphosate. I don't really use this SAR very much unless you're really concerned about the sodium levels. And here they will have, so that what they do is there's a calculation, and basically these are the factors in here that I'm just highlighting right here with my pointer, and they'll tell you, this is what this, so they'll off the water test, then they do the calculations for you, and they tell you the AMS requirement based on each of these products. And you can see again that our calcium and magnesium are really big contributors to needing that ammonium sulfate. And down here, they will have a recommended AMS required per 100 gallons of water. And here they have pounds of AMS. I'll show you in a minute how to convert that. In Canada, we're using liquid AMS. AMS, again, you can use dry AMS, but you have to weigh it, and it's fairly small amounts there per 100 gallons of water, but it also doesn't dissolve very well in cold water. So we use liquid up here in Canada because our water sources are usually very cold, especially first thing in the spring. So this is an example from Winfield United, and this is just one of theirs that they've showed me. This is a test that's come in. It's basically almost identical to the AgVise report because they send their results to AgVise, and both Winfield and AgVise are using the North Dakota NDSU factors that were developed a long time ago through a couple of scientists that were working for NDSU and doing a lot of work with adjuvants and spray water quality and things like that. So that's where these factors come from. And so in this case, this water sample is a lot less hard than the last one we were looking at. Here's the pH of 7.9. There's your sodium, your calcium, magnesium, potassium, iron. Hardness here is only 85. That's actually very low. And again, over here now they have the recommendation for how many pounds of AMS, but in here in Canada, it's liters of 34% AMS for 10 gallons of water. For 100 gallons of water. And here it's only 0.44 liters. So that's very small. The next one I'll show you is some really hard water that I actually used at the diagnostic school a couple of years ago. I got a water test done with Winfield, and the water was extremely hard and very, very poor quality, really not good for spraying at all. The pH was 7. But look at these numbers, they're an order of magnitude higher. The sodium, the calcium, the magnesium, the potassium, no iron in this case. The hardness in this case was 828. Again, that's well above that 700. And over here with that calculation, based on these factors, again, that were developed at NDSU many years ago, you end up with these recommendations over here. So this water was very, very hard compared to the example I just showed you in the previous slide. And in this case, we were talking about, again, an order of magnitude higher, 4 liters of AMS needed for every 100 gallons of water. So depending on, you really need to get a test done, because I mean, this water that I'm talking about in this case, it looked, it had a funny color to it. It actually settled out. You had to, there was actually so much mineral content in it, it would settle out. It was really terrible water, and you could see that by looking at it. But any other water sample, unless it's that bad, you will not be able to know what's in the water without getting a test, and you will not know. There are general guidelines for using ammonium sulfate, but again, if you want to know exactly how much you should use, and in some cases you don't need very much, and so again, it would save you some money if you were just using the exact amount that you needed. But there are general guidelines, and you can use just general numbers. But again, it would still be a good idea to get your water tested to know exactly what's in there. So in cases where if you're not sending it to AgVise or Winfield, again, I would strongly recommend going to one of those routes, because you can actually, you're actually getting a spray water quality test. You can send to EnviroTest, and they will do this is a test that Lionel sent me a while ago. And so you'll get a test back that looks like this. You won't get any recommendations on it, and you'll have to take these numbers and do something with them. So I'll show you, this is what page 1 of this test looks like. And here's that bicarbonate number. Here's the calcium carbonate number. Here's calcium, that's 86.6. I'll just show you the second page of this test. There's the hardness as calcium carbonate. There's dissolved iron. There's magnesium, potassium, sodium. So those are the numbers that we're concerned about. There's a lot of other things in here as well. Our pH over here is 7.39. So that's in that range that we'd like. But there's other things in this test that we don't need to know about on a spray, if we're talking just about spray water quality. And again, with a test like this, you're not able to get any recommendations. So what you can do, and I found this a couple of years ago, it's still there. I checked it again this morning, so it's still there. And this site actually from Washington State University. This is the website here, if anybody wants to take a look. It's not the easiest thing to find by Googling it. You kind of have to really search for it, or you have to know exactly what you're looking for, but it's in the wheat and small grains portion of their website. And they actually have, then if you go to weed resources, and then they actually have these tools, and they have a few different tools picking different herbicides, herbicide ratings, but this is one of the tools on there. And this is their AMS spray mix calculator. So when you click on that, you'll get something that looks like this. And so this is, again, Washington State University. And this is what they call their spray mix calculator. And it's ammonium sulfate, which is AMS, or 210024, as a water conditioner. And so basically you enter what your parts per million that have come off a water test. So this, again, was a test that Lionel had sent me a while ago, and I entered off the test. There was 86.6 parts per million calcium, 25.2 parts per million sodium, 1.7 ppm of potassium, 44.4 magnesium, basically negligible amounts of iron. And then when you calculate, you just press this calculate button, and it will actually spit out this number here. Again, this is going to be dry, but I'll show you right away how to change that. And so this is, if you don't get a water test back from a place like Winfield or AgVise directly, then you'll have to do the calculations yourself, because they will not give you, the other labs do not give you recommendations on actually how much AMS you need, but you can use this. And again, Washington State calculator, there's a bunch of other things on here, but this is the AMS sprayer mix calculator. So if you do some Googling or just you do some searching, you should be able to find that as well. So finally, then, when using ammonium sulfate, the dry does not dissolve well in cold water. So especially in the spring, especially up here in the north, we're not using the dry. We're always using the liquid. When you're using liquid AMS, we strongly recommend to use spray grade ammonium sulfate. And to convert dry to liquid, if you do get a recommendation for dry, you either multiply by 1.12 or divide by 0.9, and that's assuming a density of 3.4 pounds per gallon. So if the density was vastly different than that, you would change the formula, but that's very, very close. That's going to get you very close. And I'll just go back up and I'll show you again on this Winfield one. Here you go. And for the United States, they have 3.6 pounds of AMS per 100 gallons of water, whereas in Canada, 4.01 liters. So again, there's your calculation. So with that, that's my last slide, and I'll take questions if there are any.
Okay, Kim, yeah, there is a couple questions here. So
Sure.
just one second. Where are you sending the water samples for Winfield United. I can't really find any online when searching it.
I would be Winfield United would be like you need to look for your Canadian rep. So they have multiple reps in the province. So I would just talk to your closest Winfield rep. They have lots of reps in the province, and they have a really good tech person as well. And so between the tech person and their reps, I would talk to one of those.
Okay. Can you comment on Bayer's ammonium sulfate?
That's point.
That's 0.4 kilograms per liter conversion.
That I don't know. I'm assuming it's the same, but I guess I'd have to check the density on that. Is that, I'm just not sure. Is that the density for sure? The 0.4 kilograms per liter? That doesn't seem quite right. I'm not sure if that's density or not. I guess we just have to, if I'd have to see the label and I'd have to check the density. I just haven't looked at a jug of that in a while, but that is what we would consider spray grade ammonium sulfate.
Okay. I guess if they could maybe just let us
Yeah.
know, just one
Okay.
second, they might have,
Sure. Yeah.
that is the guaranteed.
Guarantee.
Yeah.
Okay. Yeah.
Yeah.
Okay. I'll look into that. Yeah. And I'll check into that. I'll see if I can I should be able to find a label off the PMRA site.
Okay. Regarding pH, do different products work a bit differently under different pH levels?
Yeah, generally though, if we're between that 6 to 8, then you have to watch, then like they're good, like the pH of the spray water, 6 to 8 pH. Generally we're good. You do have to watch, sometimes, certain products will have water conditioners, and that's because they don't want to drop the pH too much, or some products do drop the pH when they're added to the water. Some of the older chemistries did that, but nowadays, if there's something that if there is a product that you need a water conditioner for, or you have to have something specific in the water, it's usually included with the product itself, or there's instructions, that you must use a water conditioner for this. But normally as long as our pH is between 6 and 8, we're okay. We're okay.
Okay. Regarding the amount of ammonium sulfate, if I'm spraying 5 gallon or 10 gallon, does that change the amount of ammonium sulfate because I'm putting more product in the tank? For 5 gallons,
Usually,
I'm using.
yeah, usually the recommendation is like per 100 gallons of water. So it's because the ammonium sulfate is there to tie up the cations that are in the water. So you would just do your calculation for ammonium sulfate, or your ammonium sulfate recommendations are based per 100 or per 1,000 gallons of water, however it's reported.
Okay. Think that's all the questions that have come through right now, Kim, but again, you'll be hanging around for in case there's a couple
Yep.
that come up a little bit later.
Yep, sure. Yep.
Great, thanks. Okay, I'm just going to grab the screen back. And we're going to go into our crop scouting panel. And today we've got a few questions. I got a question last week regarding wireworm, just kind of a general question. I thought it might be a good opportunity to get John Gavlosky to come on and maybe give us a little bit of an update, or kind of go over what to look for when you're seeing wireworms or identifying wireworms and the damage they could do. So John, if you're available, and I think you got a couple slides you prepared for this.
Yes, yeah, I'll share my screen, Lionel, if that's okay.
Yep.
And yeah, we'll get my presentation up. Oops, 1 sec here. Just give me a sec here, Lionel. Just having trouble getting my screen all pulled up here.
Okay, not a problem.
Well, for whatever reason, we got a bit of technical problems getting my show up here, Lionel. So maybe what we
Okay.
can do, Lionel, is we can pop your slide back up. Sorry about that. And I'll
No
just
problem.
speak to wireworms based on the slide you've got there. So anyway, yeah, while Lionel's getting the original slide with the wireworm pulled up, just a few notes about wireworms. So wireworms, they're the larvae of click beetles, and we've actually got about 100 species of click beetles in Manitoba, but there's really just a couple of them that are pest wireworms here in the prairies. So the one in Lionel's picture here, this larger, uh, almost orangey wireworm, this one's called the prairie grain wireworm. It's not our most common. We have a smaller, paler, almost a pale yellow species called Hypnoidus bicolor, which is our dominant species here in Manitoba by far. This one here, the prairie grain wireworm, as you move west, it gets a bit more abundant, especially as you get into Saskatchewan. Um, it is much larger than our dominant species, and it also consumes more food per wireworm than our dominant species here. My one caution, if you are using Google to find information on wireworms, is all our species in the Canadian prairies are native species, so they originated here. There are some introduced wireworms in other parts of Canada. There's a group called Agriotes, where you've got species that have been introduced in BC, Atlantic Canada. Some of these species are a little different than the ones we have here, and for some crops, even more of a concern. They've been working on pheromone monitoring and a whole bunch of things for some of these Agriotes species. So if you are looking for information on wireworms, just remember that we have lots of different types. The ones in the prairies are different than the ones that are dominant in BC and Atlantic Canada. So just something to keep in mind if you're looking for ways to deal with wireworms. As far as management goes, because wireworms, the damaging stage only lives in the soil, so that the larvae only live in the soil, you can't control them with a foliar insecticide. It won't work. So seed treatments, or there is one granular, or sorry, in furrow product that can be used in corn, but for the most part, it's seed treatments that you're using. So cruiser in corn, possibly poncho. And there's a newer product called Teraxa F4. It has an active ingredient called broflanilide, which actually kills wireworms. The other products, the cruisers, and even the lumavias, they don't really kill wireworms. They kind of make them sick. They don't feed while the plants are getting established, but the wireworms don't necessarily die in big numbers. So if you are using something like a cruiser, you should get off to a good start with your crop, but the wireworms don't necessarily get killed when you're using those products. If you are using Teraxa, you should get good kill of the wireworms. The other thing I just wanted to mention, if you look really carefully at this slide, you'll notice there's three really small pair of legs up near the front of the upper wireworm. on the left-hand side there. No prolegs, so it shouldn't be something you should confuse with a cutworm. But also there's other, I'll call them worms and insect larvae in the soil that could be confused with wireworms. There's a pale white larva of a fly called stiletto fly that lives in the soil. And stiletto fly larvae are actually predators of other insects in the soil, such as wireworms. So if it's pale white, not yellowish or orange, it could be a stiletto fly larva. If it is a stiletto fly larva, if you poke at it, they go real snaky. They squirm around rapidly. They're very quick, good active hunting predators. So those are good guys. You don't need to worry about the stiletto fly larva. And just a note, if you're doing crop scouting, some of the symptoms of wireworm feeding include bare patches. So you could end up with patches where things just didn't come up well. People may write it off as poor germination for whatever reason or other problems. Dig around in those bare patches, see if potentially it's wireworms. Um, Sometimes the crop will come up, but in some crops, the stem will be a little bit shredded because of that feeding below ground. Other times, if it's cereal crops, the centermost leaves may be a bit yellow or wilty. That is a sign that wireworms could be doing some feeding, so look for that. And if you're poking around in the soil, hollowed out seeds, that could also be a result of wireworms. So those are a few of the things to look for when you're doing crop scouting for wireworms.
Okay, John, best time to look for them? Does the heat of the day make any difference, or?
Yeah, that's a good point. This time of year, they're probably going to be close to the soil surface, regardless of time of day, providing the soil isn't too dry. They don't like it when the soil gets too dry. They also don't like it when the soil gets too hot. So they will move down, especially if the soil starts drying out, they will move down deeper. And so right now, if the soil is moist this time of year, they're probably close to the soil surface. But as the soil heats up and dries out a bit later in the summer, they do move much deeper and get much trickier to find. And then late in the summer, they come up closer to the soil surface again. So, yeah, if the soil is especially quite dry and it's hot out, then you do definitely have to dig a bit deeper to find them.
Okay, and you mentioned there was a yellowish kind of more color. Can you see the pointer on my screen there?
I can, yes.
Okay, that is the picture I took. It was just that when I made it larger, it didn't work well. But that's one I took a couple of years ago. So it's kind of that yellowish color that you were talking about.
Yes, so that would be our more common species here. There's no common name for it. It's called Hypnoidus bicolor. There was a survey done from about 2018 to 2021 or two, so several years survey where we were collecting wireworms and sending them to Wim van Herken, BC, who was identifying them to species. And yeah, here that peeler one in your upper right photo, that was by far our dominant species. Prairie grain wireworm, the one in your other bigger picture, second, but a very small percentage. And then after that, we had a few other species, including a predaceous species, which is interesting because not all wireworms are strictly plant feeders. There are some predaceous species. And actually, the prairie grain wireworm, the one in your big picture, it is an opportunistic predator. If it does come across insect larvae and even other wireworms, it will eat them. And it's even been known to cannibalize other prairie grain wireworms that are smaller than them. So they're an interesting species. That Hypnoides bicolor, again, they're a smaller one, 2 to 3 year life cycle in the soil. So if you do have them this year and you just made them sick, do realize they do live for 2 or 3 years as larvae in the soil. So they can be back next year. If by chance you've got prairie grain wireworm, whole different beast. They can live anywhere from about 4 to up to about 11 years in the soil as a larva. Now, the 11 years would only be if they didn't have a lot of food. If they have good food, they'll probably 4 or 5 years, they turn into an adult. But if the food quality isn't good, they can live for up to about 11 years. And they can even do something we call a regressive molt, where they actually will do their molt, so shed their skin, and get smaller instead of bigger if they're not feeding well. And the other thing with them, if they just don't have good food for a year, they just barely eat. They do that regressive molt. So they can survive tough conditions very well. So they can be a tricky one to get rid of when you have them in big numbers.
Okay, and I remember when I had a couple producers with the problem. One of the things that we did to see, does the potato thing still work to see if you got wireworms?
Yeah, you can bait wire worms. You can either use a potato, or some people will mix a bit of oatmeal and honey and things to make these bait balls. You can do that, but do realize the way wireworms find their food is they follow carbon dioxide trails in the soil. So early in the season or very late in the season, when there's not a lot of competing carbon dioxide sources, you will get them coming to your potatoes or bait balls. Once you have a lot of green vegetation in the field, the roots are giving off carbon dioxide, which is competing with your bait traps. So the bait traps can work. They work better for some species than others. But again, once you have a lot of green vegetation competing, the effectiveness will drop off.
Yeah, and I guess usually what that just tells you is if you have wireworms, and there's really nothing you could do about it at that time anyways, right?
Well, that's the problem. If you were to put some bait out now, say some potatoes in the field, and you realize, yeah, I've got them. Now, if you haven't seeded yet, if you haven't bought your seed yet, um, then you have that opportunity to have a seed treatment on there that either kills the wireworms or stops them from feeding. But if you've already got your seed, there's really nothing you can do anyway this year. But it's good to know for the next year, of course, because then you can use seed treatments or plan your crops accordingly.
Okay, good. Thanks, John.
Okay, thank you.
Uh, sorry about that. Advancing. Okay, next question is for Marla. I had a couple producers that were looking at, I guess everybody panics when it starts to rain, so they were concerned about getting some fertilizer on that they didn't get on last fall. Looking at broadcasting, and then they were wondering about uh, what type of coating works better in the spring. Or some coatings not recommended for spring and more recommended for fall? So Marla, if you want to make maybe a few comments regarding that.
Sure, absolutely. So, I mean, obviously, the most efficient way to get your fertilizer down for nitrogen would be to band it, but recognizing that if we can't band it in the spring and we have to be broadcasting, if we're broadcasting and able to till behind, essentially, you're okay. You're decreasing potential for ammonia volatilization losses. If you're broadcasting and we're not getting that, half inch of rain right after to dissolve urea and allow that urea to move down kind of into the soil before it becomes transformed into ammonia, then you might want to be using a urease inhibitor. So that urease inhibitor is what is going to be decreasing, again, that transformation from urea to ammonia, and that is what's going to slow that potential for volatilization losses. Again, anytime you're applying a urea product or an ammonia-based product on the soil surface, it's at risk of being lost if you can't get it under the soil, either by tillage or having banded it in the first place. So the urease inhibitor is that key piece that you'd be looking at if you have to broadcast that spring nitrogen. The other inhibitors that get talked about are the nitrification inhibitors. And nitrification inhibitors, that is actually what's slowing that transformation from the ammonia form into nitrate. And that can be very helpful later on, especially if you're dealing with wetter conditions that could have that denitrification loss, the denitrification to N2O or nitrous oxide. But that comes after, again, that transformation from urea to nitrate. And so really, when we're talking about that broadcast scenario, what you're really trying to do is decrease that potential for ammonia volatilization, and that is where we need that urease inhibitor added to that urea-based product. Again, if we can get it into the soil by tillage, or if we can, expect for sure, a half inch or so of rain, then that's going to cover some of that and get that in the ground. But the worst scenario for urea is, bare urea that is to be broadcasting it onto moist soil and then not get that rain, because you get that dissolving of that urea pellet on that soil surface. And because it hasn't been driven in or moved down into the soil with rainfall, it just sits there. And then when that wind blows, you have that highest risk of volatilization. So you're going to be looking at wanting that urease inhibitor on those products if you have to broadcast in spring.
Okay, I think one of the parts of the question the producer was asking was, do some inhibitors take longer to break down than others?
Okay. All of your inhibitors, depending on what rate you're applying them, that inhibitor should buy you, 10 to 12 days of time. And that's essentially buying you time until that rainfall hits to be able to help move that product a little further into the soil. So inhibitors don't last forever. They will break down. If they inhibited forever, you'd never get access to your nitrogen. So you actually want the inhibitor to not work forever. The trick with a lot of these inhibitors, if you're using a urease inhibitor, is to make sure that if you're, looking at a product, that the application amount is what is needed for that kind of 10 to 12 days. So if you're looking at something like an agrotane, like a 30% NBPT product, if you're applying something that is a lesser rate, like 20%, for kind of the volume, then you're not going to have the same efficacy. I like to compare this to, if you're thinking about, when glyphosate came off patent, and then you have a number of different products or companies that were selling glyphosate products, and we were looking at active ingredient in order to compare back to how efficient will it be at that application rate in order to match what we had been expecting, let's say, with Roundup applications prior. So we're looking at that active ingredient and making sure that we're applying about that 30%. So if you are looking at a product that has a lesser concentration, you're going to actually have to apply it at a higher rate, which then costs a little bit more in order to ensure that you get that 10 to 12 or so days of protection.
Okay, so most products will give you that 2 weeks sort of thing.
Yeah, if applied at the correct rate or at that high enough rate, you should be able to buy that up to 2 weeks of time.
Okay, good. That's what I was looking for. Thanks. I talked the last couple crop talks about crop residue burning program, and I thought it'd be a good idea maybe just to get Timmy Ojo to come on, and Timmy is kind of the head guy for this program. So Timmy, are you on? Maybe you could make a few comments.
Yeah, I'm here, Lionel. Can you hear me okay?
You bet.
Great. Yeah, so just quickly mention that the crop residue burning program is actually regulated under the Environment Act, and the Act specifies 2 periods for the crop residue burning program. So the first period is during the active crop residue burning that usually between August 1 and November 15, right after harvest or during harvest. That's when crop residue burning seem to be, we have more proportion of crop residue burning around that period than other times of the year. And within that period, August 1st to November 15, producers would need to have to check the website to know if that day, to know the times that crop residue burning is authorized on those days, because between August 1st and November 15, we do issue specific burn times. However, other periods of the year, so like right now in May, so pretty much between November 16 and July 31, we don't have active time authorization. However, the act allows, the regulation allows for producers to burn from sunrise to sunset. That being said, producers need to check with their local RM. You need to check with your rural municipal to know if there is any local burn ban issued. So from the provincial perspective, between sunrise and sunset from November 16 to July 31, there is no requirement to request for permit from the province, except if there is a local burn permit issued for the rural municipal that the individual is at. So yeah, hopefully that clears things up.
Perfect. Thanks, Timmy. That's exactly what I was looking for. So good, thanks. Kim, are you there? Kim has done some background work here while we've been talking, and she's got an answer for the bear question. Kim, go ahead.
Yeah, that's just the same. That's just a conversion. That 0.4 kilogram per liter is a guarantee, which would be the same as like the density of 3.4 pounds per gallon. So I would assume it's the same unless you hear otherwise from Bayer or something. I will check with Bayer and also with Winfield because they sell spray grade ammonium sulfate as well. And I think the guarantee on that is a 0.4 kilogram per liter, but just if you just do the math, it's the same as a 3.4 pounds per gallon. So it's basically a density factor.
Okay, great. Thanks for doing that, Kim. A couple weed seedling identification days coming up. One on May the 22nd in Carmen at the Ian Morrison Research Farm. So if you're interested in getting an update or a refresher course on identifying weeds, good opportunity if you're in the Carmen area. And also there's going to be one in Brandon at the May the 28th at the North Hill campus. And this is one that's been kind of a regular one. I think both of them are fairly regular, but again, these ones are again a good start, I guess, when we get into the spring season, getting into identifying weeds when they're in the seedling stage. So if you're interested in getting an update, definitely two good things to take advantage of. I've been mentioning this for the last few times. The Field Crop Protection Guide is available, and I think every webinar we've had so far, we've referenced it. So definitely a lot of good information in there. So if you're needing a book or wanting a book, they're available at the Ag Services Centers, is also available through any of the field crop extension specialists. So I'll give you our numbers later on here, but if you need a book, they're a handy thing to have. And truthfully, if you're spraying, you probably should have a book. The Manitoba Hay Listing Service, kind of slowing down right now. I think most producers got the hay they need to get them through till pasture. I think pastures are greening up, and a lot of guys are looking probably within the next couple of weeks to be starting to move cows out to pasture. So I think we're good there. We talked about the crop residue burning. There's the crop protection extension people in the province. So again, if you've got questions, need help as you're out there seeding, definitely give any one of us a call, and we'll do our best to find answers for you. Or if you're needing a crop production book, we have them with us. Our livestock specialists throughout the province, there's their names, locations, and contact information. I added the Stock Talk picture on this one. They do a Stock Talk throughout most of the winter season and some through the summer. That's if you go to our Manitoba Ag website, you'll find them on there. So a lot of good information there. Our MASC service center numbers and locations, our 1-800 number, and questions, you can give myself or Lori a call. There's my phone number and both of our email addresses. And I guess with that, I'll just get Lori to check to see if there's any questions that I might have missed while we were doing this.
Nope, I don't see anything, Lionel.
Okay, great. Thanks, Lori. That concludes the webinar for today, our Crop Talk for today. And join us next week, May the 15th, and we could see how high our percentage of seeded acreage goes. And I'm guessing we're going to be knocking 30% by the end of next week, or by the 15th. So we'll see you all next week.